Story time. So there's an estate with 4 families, and in this estate, no one ever broke the estate rules, except one kid who broke the rules twice. Pause. That happened in particle physics. Oh no. Okay, let's equate. The estate is the standard model, the family is the leptons, and the silly kid is the muon. One at a time. The standard model describes what exists and how it behaves. It is a suite of equations that enumerates the fundamental particles and forces and how they interact. The leptons are one group of particles of the SM, divided into 6 flavors. Okay, go on. One of these flavors, the muon, no, not this muon, the muon, yes, was first discovered in cosmic rays. The muon is the electron's brother, same everything but weighs 207 times more. So if you were made of muons instead of electrons in you, you would weigh more. Shh. Like its brother, it has a spin. This means it is magnetic, and when placed in an external magnetic field, it will tend to align to that field and wobble like a top. That alignment is the magnetic dipole moment, and the wobble is the G factor. Can you accept that? Now, there's been a discovery that there is potentially new physics that we do not know of yet.
That's nonsense.
True! From the muon G-2 experiment, when muons are shot into a uniform magnetic field to measure their magnetic moment to the detection of their decay electrons, because muons just live for 1/1,000,000th of a second and then decay into electrons. So in 2011, a team at BNL did this experiment with great precision, but it disobeyed the standard model. 20 years later, the ring was taken to FNOW 3,200 miles away, and still something is still happening.
Wow.
So if we did not have quantum foam, particles popping into and out of existence, J would be just 2, but there is, so...
So you're telling me, after all this, that there's more I do not know?
Okay, you're saying that particles are constantly blinking like a soft soup, and you can imagine taking the muon out of that soup, making your calculations and putting it back. You see, it affects the muon's wobble, and then it seems like there's something else inside that soup, like an alpha spaghetti, and the muon being heavier is more sensitive to that thing. Of course, but it's not yet a particle physics discovery yet. It has a certain certainty of 5 sigma, but from 3.4 sigma, it's now 4.2 sigma. The chance of this being a fluke is 1 in 40,000. I mean, not enough that I could bet my life on, but...
What are they going to look for? Right in our physics textbooks.